Okay, whoops. So I forgot to start recording. Let's just write that again. So if we're writing a function, we start with the keyword function and then the name of the function. We use the same convention as a variable name. So this function is called banana. If I was going to add a second name to it, like orange, I would capitalize the second word. After the name, we have parentheses. And we don't have to have anything in the parentheses. Sometimes they're just on their own, but sometimes we're going to put stuff in the parentheses. Like when we write ellipse, there's usually like numbers or other variables in here. So we'll talk about that in a second. But for now, we're just going to have the parentheses empty. And then we have curly brackets for our code block. So everything that's inside of the curly brackets is part of our function. Anytime we run the function, we run the code that's inside the curly brackets. So for now, I'm just going to say console.log, and I'm going to log banana. Okay, so these don't have to match. I'm just using this as an example. This is just a string. Let's say I like bananas. So if I run this code and I look in the console, there's nothing in there. So nothing happened. So this is just a function declaration. Okay, so it's a little bit like saying variable x equals 0. We're declaring x and initializing the value. I'm not going to write this out because I'm going to delete it. With a function, we're declaring that the function exists. So this is called defining a function. And then if we actually want to run the code in the function, we have to call or invoke the function. And to do that, we just type the function name with the parentheses at the end as a statement in our code. So now if I run this code, we get the log, I like bananas. And we can call it as many times as we want. So this doesn't have much utility, but if we were drawing ellipses or squares or something like that, it would have more utility. You can see it's actually logging twice because there's a 2 there, but it's on the same line because it's the same thing. That's something that the console will do to save space. So yeah. So one thing that you might be wondering about is when we say function start or function draw, something like that, we don't actually ever call it. And that's because P5 is doing it for us. That's specific to the architecture of P5, the way that P5 works. It's not usually how most programs work, but it's something that P5 does for us so we can get started a little bit faster. And same thing with all the functions that we use in P5, like ellipse, stuff like that. We don't actually have to write those definitions because P5 defines them for us. P5 is basically a bunch of different functions and values that are predefined so that we can get started drawing and doing interactive art without having to define them all ourselves. So we've created a function. So now let's talk about arguments. So functions often have arguments. Arguments are things that go inside the parentheses. They're sort of like parameters that determine how the function works. You can think about this as like a blender. A blender is a machine that always does the same thing, right? You hit the button and it blends, and whatever's inside the blender gets blended. There's certain things that you can change, and you can think of those as like arguments or parameters. Like you can change the amount of time that the things are blended for. You can change, how fast the motor is running while it's blending. You can change what goes into the blender. Like you could put some, fruit in there to make a smoothie. You could put some greens in there to make like a green juice or something like that. But the blender always does the same thing. It's what you put into it changes what you get out of it. Same thing with our ellipse. When we draw an ellipse, we always get a circle, but sometimes it's in a different place. Sometimes it's a different size. And so those are what the arguments do. They change the parameters of what we're doing with our function. So I'm going to write another function called greet. So I'm going to define the function greet, and this function takes a couple of arguments. So what we want to do when we're thinking about how to create a function, we want to think about what are the things that can be different. So like when I draw an ellipse, I always want it to look like a circle, but sometimes I want it to be right side of the canvas or left side of the canvas. Sometimes I want it to be really big or really small, depending on what I want it to be, what part of my drawing I'm doing. So when we think about what do we need for our function, what are the arguments, we have to think about what does the function do and how could it be different. So with my greet function, I just want to greet somebody. So let's imagine I'm just saying, hello, comma, Jerry. So it's a really simple function. Let's put a little exclamation point here. And if I call the function, so I have to, after I define the function, I have to call it. So I'm going to greet. And so let's open our console and see what that looks like. So we get hello, Jerry. So I always want to print out a statement. That's not going to change. But what I might want to print out is what the greeting is. It could be like hi or hey. And I want to change what the person's name might be. Okay, so let's start with the name. So I'm going to put name here. And then I'm going to replace this part of my data with the variable name. And so an argument, when I create an argument here, it's sort of like saying variable name equals Jerry, except this Jerry becomes an argument that I can change when I call the function. So I'm going to take this data, the string here, and I'm going to put it down here. And so now when Jerry goes here, that becomes the name. So this automatically creates a new variable that's only inside of my function. It doesn't exist anywhere else. And that variable is name. So now I can adjust my my program to use the variable instead of the hard-coded data. So I'm going to delete Jerry, and I'm just going to add name in between my string. Okay, so now it'll still work the same, but now I can greet other people. I can greet Jenny. So the first time I invoke, I have Jerry as the argument. So it says hello, Jerry. And then I can greet Jenny, and it says hello, Jenny. So I can also change the greeting. So I can add a second argument, and I can add as many arguments as I want, and they can be of different data types like strings, Booleans, numbers, whatever I want to use. So for my greeting, remember, this is basically like saying variable greeting equals hello. Okay, so if we say variable greeting equals hello, I can replace the string hello with my greeting variable. So then now I can say greeting plus comma plus name. And now that I have an argument for that, I can change it. So if I put hello as the second argument for Jerry, and then for Jenny, instead of hello, I can say hi. Now I can get rid of this, and now we're going to use that second argument. So I have hello, Jerry, and then I have hi, Jenny, and I can use this function as many times as I want with, however, any different type of name, any combination of name and greeting, and it's going to fit those in there for me. So the order of the arguments matters in this case. If I reverse this, like if I say greet Larry, or if I say greet hey and Larry, it's going to say Larry hey, which I guess is not that bad. It's still kind of grammatical, but it's not like what I wanted, right? The hey is actually becoming the name, and the name is going over here, and Larry is becoming the greeting, and the greeting is going over here. So if you ever put in the y value into your rectangle or your ellipse or something like that in the wrong position, you might have seen that it gets applied differently. So the order of the arguments matters when we're writing functions. If I forget my arguments, so if I just say greet, we're going to see this, undefined, undefined. So if we have these arguments, but we don't actually give them values, then on the other side, they're just undefined. They don't have a value. And so that's obviously a bug. That's not what we want our function to do. So P5, you know how there's some optional arguments? And so if you have an optional argument, it may say something like this. If there's no name, name equals Jerry. So it may have it, this isn't always how it would be written, but this is one way to write it. This is a way to make sure that if the person who is using the function didn't actually put in a name, then it can fill in the name here. So if no name, so that means that name is, undefined or something like that. So now it just says undefined Jerry. So in P5, when you have an optional argument, if the function still works, that's because it has some sort of default to capture if you put in if you don't put in the right number of arguments. Okay. Let's see. Okay. Any questions about arguments? Okay. So let's talk about scope for a second. We've talked about this a little bit before when we talked about global variables. But when we create an argument, I'm going to get rid of this for now. When we create an argument, this only exists inside of this function. So if I come down here and I try to log name, you're going to see that it doesn't exist. Although it is an empty string, which is kind of interesting. It should be undefined. See what happens if I put it up here. It's not really what I was expecting. If I put greeting. Yeah, that's what I was expecting. So name must mean something in the P5 global space. So that's not a good example. Okay, so if I say console.log greeting, even though I have a greeting up here and I've used it in my functions, it doesn't exist. It only exists inside of this function. If I create a greeting for some reason, like if I have variable greeting equals hi, I guess I wouldn't want to say, okay, I said hello, hi, and hey. Let's say salutations. Okay, so I created this variable greeting, but it doesn't get used anywhere because this greeting overrides it inside of my greet function. So this is another thing with scope. Even if though I have this global greeting value that you think would be working inside of here, because I have a greeting variable here, it overwrites it. So within this function, if it has the same name, it changes. If I change this to like, greeting global, now it'll exist in here. I'm not actually using it, but just to show, if I say greeting global, I'm still getting this error down here, so let's get rid of that. So now you see it says salutations here. So that the variables get overwritten if they have the same name. And that's another, the main thing that we see that is when we're trying to use X and Y variables to do animation or do something like that. If we have that, if we have our X and Y declared inside of our draw function, then we're going to run into issues because they're going to get overwritten. Hey, Ruben, you all right? Do you want to leave and you can come back when you're ready? All right. So we're going to make some functions in P5. And we'll start out with a quick example of making a function, and then we'll add some into our pattern. So what we're going to do is make a function that has some functionality built into it. So I'm going to leave this here and make a new editor. Let's see. Okay, so I'll save this as button function example. And it's 4. So what we're going to do is we're going to use a function to put a bunch of functionality that we want to repeat without having to copy and paste it a bunch of times. So it's kind of similar to a loop, and we're going to use it together with a loop, but it's for adding a bunch of other stuff in that we don't necessarily want to have, copied over and over again. So let's create the thing that we're going to make first, and then we'll turn it into a function. So we're going to create a button, and we're going to talk a little bit about, we're going to use a function in P5 that we haven't used before to make the button work, but let's just create the button first. And it's not actually a button that's going to do anything. We're just going to use it to show that the mouse is hovering. So I'm just going to draw an ellipse. And I'm using an ellipse because it's a little bit easier to do the math. We'll look at how to do a rectangle button in a couple weeks. So I'm going to draw an ellipse. I'll just draw it in the middle of the canvas, so 200, 200. I'll make it 100 pixels. Okay. And so what I want to do is create a function that if I hover over the ellipse with the mouse, it changes the color of the ellipse. So let's fill the ellipse. I'm going to use plum. Oh, this is new. I haven't seen this before. I think P5 must have added this so I can see. That's actually really cool. We can see the color values here. So we could take the RGB values and throw them in there if we want to. Or can we just change the color to? Oh wow, yeah, that's pretty cool. I think they must have just added that. There's some basic colors here too. Cool. Anyway, so I'm gonna fill plum, and let's see. Let's turn off the stroke. So I'll say no stroke. Actually, let's leave on the stroke. I'm just gonna make it a little bigger. I'm gonna say stroke weight is 4. That'll be useful to see the boundaries. Okay, so what I want to do is detect whether my mouse is inside the circle. So this is a little bit of a tangent, but we're gonna be able to talk about some conditional logic, doing some math and stuff like that. And so essentially what I'm doing is I want to know if the mouse is inside of the circle or not. And there's a pretty easy way to do that mathematically. We know where our mouse is. We know the XY position of the mouse. We also know where the center of the circle is, right? And we also know the radius of the circle, which is half of the size or diameter, so the radius is like 50. And so we know, since it's a circle, as long as the mouse is within 50 pixels of the center of the circle, that radius, it's inside the circle, right? Because it's a circle, it's the same, if the radius is the same distance all the way around. So if the mouse is over here, it's going to be greater than 50 away from the edge of the circle. If it's in here, it's going to be less than 50. So what we have to do is find the distance from the mouse to the center. That's the tricky part, but there's a function that will do it for us. And if you guys remember from geometry, it's just a Pythagorean theorem. To find the distance, you're just going to take the difference in x squared plus the difference in y squared gives you the length squared. But we don't have to do that math. We can just use distance. So we can say variable d for distance equals dist. So dist is the function that'll do that calculation for us. And we just have to put in the mouse x, mouse y. That's the first position that we want to calculate the distance. And then the second position is this 200, 200, which is the center of the circle. So now I'm just going to draw what D is. I'll put it in the upper left corner. And I'll fill in black so we can see it. Okay, make it a little bigger. And I'm just gonna round it so we don't see the decimal point. Okay, so if the mouse is really close to the center of the circle, the distance is very small. Let's see if I can get it to 0. Yeah, 0. And if I'm around the edge, it's around 50, right? Because we know the radius of the circle is 50. If I'm outside of that, and then it's going to be greater than 50. So all we have to know is if d is less than 50, if the distance is less than half the size. So if d is less than 50, we're going to fill with the plum. And if it's not, so any other case, let's fill with blue. Okay, so inside, outside. So it works pretty well. Because as long as it's a circle, that radius is always going to be the distance to the edge of the circle. Okay, so let's delete this. And so now we have this like pretty complicated bit of code, right? It's like 1, 2, 3, 4, 5, 6, 7 lines. And it produces one pretty basic thing. It's a circle that knows when we hover over it. And so if we want to extrapolate this into a function so we can make a lot of them, or if we want to make a lot of buttons that can behave independently, then what we need to be able to do is abstract this drawing into a function. We don't want to copy and paste this code over and over and over again if we want multiple buttons. So when we're creating a new function, usually what I'll do, let's just close the draw function and start a new function, function button. Okay, so that's pretty easy. You don't have to do it that way, but I created this button thing inside my draw loop, and I want to abstract it into its own thing. So I can just close the draw function, just throw in a curly bracket there, and then start my new button function. Okay, but now the button's gone, right? Because I'm not invoking the button. So I've defined my button, which is something that we haven't done with P5 before. Usually we use the things that they've defined for us, but I haven't called the button. So just like I do with my ellipse, I need to call the button. Okay, now it's working. But if we put in different parameters, like if I want my button to be at 300, and I want the size to be 50, nothing changes, right? Because I haven't actually added any arguments. I haven't made variables to change where the button goes. So that's what we'll do next. And we really could add more arguments than this, but we'll start with this. So usually when we draw an ellipse, we're going to say like, ellipse, x, y, size, like that. So that's what we're actually doing on our own this time with this specific button. So we don't have to use the same order of arguments that P5 usually uses, but obviously since we're working with P5, it makes sense to keep the same basic setup. So let's start with the x. So if I want my x to be 300, we can put x as the first argument in my button. Okay, that's going to grab that 300 from there. And then I just have to find things that are using x and replace it with my new x argument. So when I calculate the distance in the button, it's the distance between mouse x, mouse y, and the middle of the button, which is at the xy value. So I'll put x there. And then when I'm actually drawing the button down here, the first argument obviously is going to be x. Okay, so now we've got our button over there. Okay, so let's copy this and paste it, and let's put another button at 100. Okay, so now we have two buttons that behave independently, but we can't do different sizes. If I wanted this button to be 100, and we can't do different y values. Let's say I wanted this button to be up there. So right now, the only thing that can be different is the x. So let's continue. So the next thing that we want to change is y. So let's add another argument for y. And now we just have to find the values where this goes. So there's one here, right? The distance between the mouse and the circle, mouse x, mouse y, x and y. And then down here, when we draw our ellipse, we need that y. Okay, so now I have my buttons and I can change the y. Everything's still working. The last bit is the size, right? So let's put in S for size. We have to use S because size is taken by P5 already. So now this 50 is actually size over 2, right? Because the size of the circle is 2 times the radius. The size is the full width or height or diameter of the circle. The radius is just half that. So we can put in S for the 100, but we need to put in S over 2 for the radius. Okay, so now we have a big button and a little button. And now I can make as many buttons as I want. I can say button at 300x, 100y, and make it even bigger, 200. Got a button there. And we can also do a button at 100x, 300y, make this one really small. So the buttons don't actually do anything. Obviously, we need to do more with this to make them have other things that happen. But we can, start to create our own functions that have specific functionality that we can recreate. So instead of having to calculate the distance of a bunch of different stuff and figure all this out and rewrite the code over and over again, if I can abstract the idea of a button into its own function, then I can reuse it as many times as I want. So further things I could change could be like the color that we hover over. So you can add as much stuff in here as you want to be different. So let's add a new color. So let's do C for color, and this will be the hover color. So we can start with plum for one of them, but then we could do some other colors. Let's do yellow and green and red. And so now we just take the C and switch the fill there. So each one of our buttons has a new color. So we can figure out what can I change, and then how do I represent that in my arguments. All right, I have one more example I'm going to do with the loop. Let me just make sure I covered everything in here. Yeah, okay. So I'm going to do one more example where I'm going to use my loop. Any questions? Okay. So I'm going to open another window. And so when we're looking at this, you can see I'm repeating the button a bunch of times. And if you remember what we did last week when we did the loop, we went from repeating our ellipse a bunch of times to creating a loop to repeat it. So our functions and our loops can work together to help us create more interesting patterns. So I'm going to open up the last pattern sketch I did. Let's see. Is it drawing with loops? Yeah, okay, I'm going to use this one. I'm going to simplify it a little bit and then add a function to it. So let's go in here and duplicate. And I'm going to say loop plus function. Okay, and I'm going to get rid of some of the variations here that I don't really want to use. So I'm going to get rid of this y variation and the count and the color. And for the fill, I'll just do plum. For the y, let's just do 200. Oh, okay, I'll just say let y equal 200. Okay, and then I did a weird fill down here. Let's just do white for the fill. And let's do no stroke. Okay, so I have this little pattern. Let's say I want to make it interactive. So my code is getting pretty complicated here in my for loop. There's a lot of different things going on, and it's kind of hard to read this way. So a lot of time when I'm writing code, what I want to do is simplify my code the way it reads by adding abstractions. So just like with our button, in our button sketch, it's easier to understand what's going on here because I'm saying, I have a button, I have another button, I have another button, I have another button, and I don't even have to read this button function if I don't want to. I can just look at, okay, I have this button. If I want to move it, I can change the number. If I want to change the color, I can do that. I don't even really have to think about how it's actually being created if I don't want to. So we can simplify the way our code reads by adding abstractions. So in this one, I can't just close my draw function. It's a little bit more complicated. So I'm going to create a new function, and I'm going to call this function, I guess it's like a self-portrait. I probably can't use self because I'm sure that is something. I'll just call it me. Yeah, that's fine. I'll just call it me. And so now I can just grab all this code, dump it in there. It's going to look kind of weird, but I'm going to auto format in a second. And now I can say me at x instead of all this code. And I just have to make sure x goes in here because I was already using x. I don't really have to change anything else. Okay, still works exactly the same way. Me is probably not the best. I'm just going to do self-portrait because me is like kind of confusing. Okay. And so some of the indentations are off because I copied this code. So I'm going to go to tidy code. And so now that looks better. So now we have these two separate parts of our program that are doing two separate things. One is my loop. So it's saying, I'm drawing a bunch of self-portraits, a pattern of self-portraits. And the other function is just the actual self-portrait. So it's much easier now to say, if I want to change what's happening in one part of my self-portrait, I can just focus on this code down here. If I want to change the way that the loop works, like let's say I want to space them out a little bit, I can do this over here, but I don't actually have to work with the both parts at the same time. It kind of simplifies the structure of my code. So let's add a little interaction in here. I want to make it so that if I click on each one, the expression changes. So I can maybe make the eyes wider. I can make the mouth jump up, something simple. So if I want to make the eyes wider, I have to change the size. So let's say variable I, and let's use let here actually, since we're in a function. Remember, let only exists inside of the function, whereas var will make the variable exist everywhere. So I'm going to say let I size equals 20. And then I'm going to replace the I size here. And now I'm going to say if, and so now I'm actually going to use is my mouse clicking, but am I also inside of the circle? So let's start with if mouse is pressed. Then we're going to say I size equals 40. So what this is going to do is it's going to change every single one of my expressions because I'm not checking to see where the mouse is. I'm just doing it if the mouse is pressed. So we can combine these two different conditions if the mouse is pressed and if our distance is inside of our circle. So let's calculate that. So we can say let d for distance, same thing we did with the button. So we want to know the distance between mouse X and mouse Y and the size of the self-portrait. So that's right here, this 100. And we want half of that since it's the radius. So the X and Y is just the X and Y. And then if, actually, let's just add it in here. So if mouse is pressed and, so I can do a double ampersand to combine my two conditions. So if the mouse is pressed and D is less than 50. So 50 is half of 100. And so I know that my self-portrait, my mouse will be inside of the self-portrait. And so if I run this, now the self-portrait that I click on changes expression. So I can change like the mouth size as well. I could actually just plug in eye size here. But I might want to use another variable. So I could say let mouth size. So I could start at like 10. And if I click, I could say mouth size equals, say 50. We'll do a more dramatic one with this one. So I'll put that in there for the height of the mouth. And the eyes are also overlapping a little bit, so maybe we could change this number as well. We really wanted to, could say like, let I offset equals 20 and I offset equals 50. And then I could put that in for this 20 here. So then the right eye will move over. It's a little bit too far, but at least they're not overlapping anymore. Anyway, I can, change the color. I can do all sorts of different stuff to change the effect of what's happening in here. And so now I have this self-portrait to deal with how the self-portrait works. And if I'm done with this, I can close this up. And if I want to change where they're being drawn, I can go up here and just think about where are they being drawn. So if I want to move them over, I could say they start at 50 or maybe 60. And if I want them to be more spaced out, I can change X 140. So I have these two different parts of my program that kind of control different aspects of what's going on. All right, I think that's good for now. I'm going to save this. I'm going to stop recording.